there's a big fraction right here. There's the big fraction. And then there's little fractions. So this is a little fraction right here. This is a little fraction right here. So a complex fraction is little fractions inside of the big fraction. We have to multiply the top and the bottom by the little common denominator, which means, what I mean by that is the common denominator between 3 and x is pretty straightforward. It's just 3x. I can make both of those 3x. I'm going to multiply the top and the bottom by 3x to get rid of both of those denominators. And I can do that because I'm multiplying by 1, 3x over 3x. And now it's just the distributive property. When I multiply x over 3 times 3x, I'm going to use this 3x 4 times. I'm going to use it, when you distribute, you use it every time you multiply again. So really I'm going to use the 3x, like I said, 4 times, 1 for each of those. That's what distributive property is. When I use 3x for this first one, the 3's cancel. 3 over 3 is 1. What I'm left with is x times x. So we have x squared. But the fraction's gone. Inside, the little fraction's gone. And then when I take 3x times 6, it's minus 18x. Not much you can do with that. So that's the top. Little fraction is gone. Over, I'm going to use 3x. I'm distributing it through, so I'm using 3x twice. That's just going to be 30x. 30x. And on this one, when I multiply here, these x's cancel, and I'm left with plus 12. Now what you have to guard against is, does this simplify? If I take an x out of the top, I get x minus 18. If I take a 6 out of the bottom, I get 5x plus 2. So as it turns out, nothing cancels. We don't have anything that's the same on the top and the bottom. But you always kind of want to be aware that's a possibility. It doesn't usually happen though. Go ahead.
So this might be a stupid question, but how come the x's don't cancel on the top and they do on the bottom?
This is like 3x over 1. You okay with that? To multiply, you multiply straight across. Straight across. So this becomes, this is not a dumb question at all, this becomes 3x squared over 3. That's why these cancel, right?
Yeah.
But then over here, this becomes 12x over x. That's why those cancel. Is that a good explanation?
Yeah.
Okay, very good. Any other questions on this? There's our next one. 6, 3, 5, and 10. I think I got it. Do you know what the common denominator would be between those 4 numbers? It would be 30. That's right. It would be 30. So I need to multiply everything times 30. So really what you're doing is you're multiplying the top and the bottom by 30. Now there's no variables in the denominator, so I don't have to worry about multiplying by any variables. But when you distribute, you use the 30 once for this one and then once for that one. So I just usually put 30s all the way around because I'm going to reuse the 30. If we do this like I showed Michael up here, it would be 30x over 6 minus 30x over 3 over 30x over 5 minus, that's going to be 210 over 10, right? We could do it this way. And then 30 divided, when I do this, if I truly have the right common denominator, all the denominators, all the little denominators should go away. 30 divided by 6 is 5. 30 divided by 3 is 10. 30 divided by 5 is 6. 210 divided by 10 is actually 21. See, all the little denominators are gone. No more complex fraction. Now we just deal with whatever's left over. This becomes negative 5x over 6x minus 21. Right? Do those x's cancel? No. It's part of addition or subtraction. So that's what we're looking for right there. Any questions on that one? Go ahead. So 5x minus 10x, 5 minus 10 is negative 5. Now, let me show you this. If it was 5x minus 10 over 6x minus 21, can I subtract the top now? No, it's not the same. It must be same variables, the same powers in order to combine like this right here. Very good. Just like when you had two things and you had to find the common denominator, this is very similar. We have three little denominators, x plus 4, and x. So really we only have two unique little denominators. I need to multiply by the common denominator, which is both of those. And I need to multiply the top and bottom by that, but since I'm distributing it through, I'm really using this 3 times. 3 times because of the distributive property. On top, because we have an x plus 4 on top and an x plus 4 on the bottom, these cancel out with each other, and all I'm left with on top is 5x. On this next one, the same thing happens. The x plus 4's cancel, but I'm left with x there. And then over here, the x's cancel, so I have a little bit more to do on this one because 2 times x plus 4 is left over. So I have a little bit of simplifying to do in the denominator on this one. That's 5x over x plus 2x plus 8. 5x over 3x plus 8. 2 plus 1 being 3. Those x's do not cancel. You cannot cancel parts of addition or parts of subtraction. You can cancel the whole thing. I can do all of this with all of this because really you're canceling a part of multiplication. That's fine. Questions on this one? Got to find that common little denominator. Nothing down there. Next, everything else. One more. One more. We only have 2 unique little denominators. We have x plus 5 and x minus 3. And we're going to use that 3 times. Really, I'm multiplying the top and bottom by that, but I'm distributing on the bottom, which means we reuse it for this one. Now, the whole point of this is that this is going to cancel out that little denominator. And we're left with a little bit of math to do. 3 times x minus 3 on the top there. Cancel, that cancels out, so it's over 2 times x plus 5. And then over here, the x plus 5's cancel. Those are gone. We have plus x minus 3. This is what we have left to deal with. Any questions so far? I'm canceling out those little denominators. Now we got a little bit of algebra to do. 3x minus 9 over 2x plus 10 plus x minus 3. 3x minus 9 over, looks like 3x plus 7. Do those 3x cancel? Is it those 3x's, do they cancel? Are you sure? Have I made that point really clear? Somebody's going to do that on the test. Somebody is going to cancel those 3x's out. It's like a big tidal wave coming at me, and I'm trying to stop it, but I just can't. I'm trying to hold the water back, but it's going to hit me. It's going to hit me when I grade it. Who's it going to be? It's going to be Kaylee? It's going to be Robbie? I don't know. We're going to find out. Anyway, without being sarcastic and trying to make a joke out of it, you can't cancel parts of addition or subtraction. Now, if that said 3x times x minus 1, 3x times x plus 3, could I cancel those 3x's now?
Yeah.
Absolutely. Sure can. It's because the 3x is only involved with multiplication now. Anyway, I just don't want you to make that mistake. I mean, I'm your best ally. I'm for you. I want these tests to be awesome. I really do. Anyway, last one. How many little denominators do we have here? 1. Not a whole lot of choices to multiply by, right? 2y, 2y. I guess we saved the easiest one for last, in my opinion. So we got to use 2y 3 times. We get 6y over 2y, plus 1. Now when those cancel, that's really 1 times 1. So it's just, well, that's it. If you cancel those 6y, 2y, I will sigh heavily when I grade this test. I'll be like, ugh. Anyway, then I'll move on. That wasn't too bad.